Emergency branch circuits generally cannot share the same raceway with normal branch circuits. The key exception to this rule is when a fire-resistant barrier is installed within the raceway to physically separate the emergency circuits from the normal circuits. This requirement is in place to ensure that emergency systems remain operational during a fire or other event that could compromise normal power. The reasoning behind the separation is to prevent a fault or failure in the normal branch circuits from affecting the emergency circuits. Emergency systems such as emergency lighting, fire alarm systems, and emergency generators are critical for life safety and must function reliably even when the normal power supply is disrupted. If normal and emergency circuits were allowed to freely share the same raceway without a barrier, a single event such as a short circuit or ground fault in the normal wiring could potentially damage or disable both the normal and emergency circuits, defeating the purpose of having an emergency system in the first place. The fire-resistant barrier acts as a protective shield, preventing the spread of heat, flames, and smoke from the normal circuits to the emergency circuits. This barrier helps to maintain the integrity of the emergency system, allowing it to continue functioning during an emergency. The specific requirements for fire-resistant barriers are typically outlined in the National Electrical Code, or NEC, and other relevant electrical codes and standards. These codes specify the types of materials that can be used for the barrier, the minimum thickness of the barrier, and the methods for installing the barrier. The NEC addresses this in section 700.9. This section states that emergency wiring shall be kept entirely independent of all other wiring and equipment, and shall not enter the same raceway, cable, box, or cabinet with other wiring. There are exceptions. The first exception is general. Wiring of an emergency system shall be permitted to occupy the same raceway, cable, box, or cabinet with one or more non-emergency systems were identified for, and connected to, only the emergency system. The second exception focuses on transfer equipment. Wiring of two or more emergency systems shall be permitted to occupy the same raceway, cable, box, or cabinet. Thirdly, fire alarm circuits are addressed. Fire alarm circuits in the same raceway are allowed when they are part of the emergency system. The fourth exception allows for certain monitoring circuits. Sensor circuits or circuits that monitor the status of the emergency source are allowed. The final exception is for the shunt trip control. If the normal and emergency sources are in the same enclosure, the wiring for the shunt trip control is allowed to be in the same raceway or enclosure. In practice, this means that if you are running both normal and emergency circuits in a building, you will typically need to install separate raceways for each type of circuit. This can add to the cost and complexity of the electrical installation, but it is essential for ensuring the safety and reliability of the emergency system. There are different types of fire-resistant materials that can be used for barriers in raceways. Some common examples include fire-rated sealants, intumescent materials, and mineral wool. Fire-rated sealants are used to seal openings and penetrations in fire-rated walls and floors. These sealants expand when exposed to heat, creating a barrier that prevents the spread of fire and smoke. Intumescent materials are also designed to expand when exposed to heat. These materials are often used to protect electrical cables and conduits from fire. Mineral wool is a type of insulation that is made from mineral fibers. It is highly resistant to heat and fire and is often used to insulate walls, floors, and ceilings. When installing a fire-resistant barrier in a raceway, it is important to follow the manufacturer's instructions carefully. The barrier must be installed correctly to be effective. It is also important to ensure that the barrier is properly maintained over time. Barriers can be damaged by physical impact or exposure to moisture, so it is important to inspect them regularly and repair any damage promptly. In addition to the fire-resistant barrier requirement, there are other regulations that govern the installation of emergency circuits. For example, the NEC requires that emergency circuits be clearly identified and marked. This helps to ensure that electricians and other personnel can easily identify the emergency circuits in the event of an emergency. The NEC also requires that emergency circuits be tested regularly to ensure that they are functioning properly. These tests should be performed by a qualified electrician and should be documented in writing. It is also important to consider the type of raceway that is used for emergency circuits. Metal raceways, such as conduit, are generally preferred over non-metallic raceways, such as PVC conduit. Metal raceways provide better protection for the emergency circuits from fire and physical damage. When selecting a raceway for emergency circuits, it is important to consider the environmental conditions in which the raceway will be installed. If the raceway will be exposed to moisture or corrosive chemicals, it is important to choose a raceway that is suitable for those conditions. In some cases, it may be necessary to use a special type of raceway, such as a liquid-tight conduit, to protect the emergency circuits from moisture. Another important consideration is the size of the raceway. The raceway must be large enough to accommodate all of the wires and cables that will be installed in it. It is also important to leave some extra space in the raceway for future expansion. When installing emergency circuits, it is important to follow all applicable electrical codes and standards. These codes and standards are designed to ensure the safety and reliability of electrical installations. Failure to follow these codes and standards can result in serious injury or death. The installation of emergency circuits should only be performed by a qualified electrician. Electricians have the training and experience necessary to install emergency circuits safely and correctly. When hiring an electrician to install emergency circuits, it is important to check their credentials and references. Make sure that the electrician is licensed and insured and that they have experience installing emergency circuits. It is also a good idea to get multiple bids from different electricians before making a decision. In addition to the NEC, there may be other local or state electrical codes that apply to the installation of emergency circuits. It is important to check with your local building department to find out what codes are in effect in your area. Emergency circuits are a critical component of any building's safety system. By following the proper installation procedures and adhering to all applicable codes and standards, you can help to ensure that emergency circuits will function reliably in the event of an emergency. Consider a scenario where a fire breaks out in a commercial building. The normal power supply is disrupted, plunging the building into darkness. However, the emergency lighting system, powered by emergency circuits, immediately activates, illuminating the exit routes and allowing occupants to safely evacuate the building. The fire alarm system, also powered by emergency circuits, continues to sound, alerting occupants to the danger and prompting them to take action. Without these emergency systems, the consequences of the fire could have been much more severe. Emergency circuits are not just for fires. They can also be used to power other critical systems, such as medical equipment in hospitals, security systems in banks, and communication systems in emergency response centers. In these situations, the reliable operation of emergency circuits is essential for protecting lives and property. Firstly, understand the purpose of emergency circuits, which is to provide power to critical systems during a power outage or other emergency situation. Secondly, know the NEC requirements for emergency circuits, including the requirement for fire-resistant barriers and raceways shared with normal circuits. Thirdly, use only qualified electricians to install and maintain emergency circuits. Fourthly, inspect and test emergency circuits regularly to ensure that they are functioning properly. Fifthly, keep accurate records of all emergency circuit installations, inspections, and tests. Sixthly, ensure that all building occupants are aware of the location of emergency exits and the operation of emergency systems. Seventhly, develop and implement a comprehensive emergency plan that includes procedures for responding to power outages and other emergencies. Eighthly, conduct regular drills to practice the emergency plan. Ninthly, review and update the emergency plan regularly to ensure that it is effective. Tenthly, work with local emergency responders to coordinate emergency preparedness efforts. By taking these steps, you can help to ensure that your building is prepared for any emergency. The National Electrical Code, specifically Section 700, covers emergency systems. These are electrical systems designed to provide power automatically to critical equipment and lighting when the normal power supply fails. Emergency systems are essential for safety in buildings and facilities where immediate power is necessary to prevent hazards, ensure life safety, and facilitate emergency operations. Section 700.1 states the scope which covers the installation, operation, maintenance, and testing requirements for emergency systems. These systems are intended to supply, distribute, and control electricity for illumination, power, and signaling essential for life safety and hazard mitigation. Emergency systems are typically installed in places such as hospitals, fire stations, police stations, and other critical facilities. 700.3 covers tests and maintenance. Emergency systems must be regularly tested to ensure they function correctly during a power outage. This includes periodic testing of generators, transfer switches, batteries, and other components of the emergency system. Maintenance is also critical. Regular maintenance must be performed on emergency systems to ensure their reliability. This includes inspecting and servicing generators, transfer switches, batteries, and other components. Records of testing and maintenance must be maintained. Detailed records of all tests and maintenance activities must be kept. These records should include the date of the test or maintenance, the results of the test, and any repairs or adjustments made. Section 700.8 covers signs. Emergency systems must be clearly marked with appropriate signs to indicate their purpose and location. These signs should be visible and easily understood by building occupants and emergency responders. Section 700.10 covers wiring. All wiring for emergency systems must comply with the requirements of the NEC, including the use of appropriate conductors, raceways, and overcurrent protection devices. As previously mentioned in 700.9, wiring for emergency systems must be kept separate from normal wiring to prevent a fault in the normal wiring from affecting the emergency system. Emergency power sources are covered in 700.12. Emergency systems must have a reliable power source, such as a generator, battery, or uninterruptible power supply, or UPS. The power source must be capable of providing power for the duration required by the applicable codes and standards. Transfer equipment is also important and is covered in 700.5. Emergency systems must have automatic transfer switches that automatically transfer the load from the normal power source to the emergency power source in the event of a power outage. The transfer switches must be reliable and capable of handling the load requirements of the emergency system. Overcurrent protection is covered in 700.27. Emergency systems must have overcurrent protection devices, such as circuit breakers and fuses, to protect the wiring and equipment from overloads and short circuits. These overcurrent protection devices must be sized appropriately for the emergency system. Lighting is covered in 700.16. Emergency lighting must be provided in areas where it is essential for life safety, such as exit routes, stairwells, and assembly areas. The emergency lighting must provide adequate illumination to allow occupants to safely evacuate the building. In summary, emergency circuits and systems are critical for safety in buildings and facilities where immediate power is necessary to prevent hazards, ensure life safety, and facilitate emergency operations. It is essential to follow all applicable codes and standards when installing, operating, and maintaining emergency systems. Consider a large data center that requires continuous power to operate its servers and other critical equipment. A power outage could result in significant data loss, financial losses, and damage to the company's reputation. To prevent these consequences, the data center has installed an emergency power system that includes generators, transfer switches, and UPS systems. In the event of a power outage, the transfer switches automatically transfer the load from the normal power source to the generators, which provide backup power to the data center. The UPS systems provide a seamless transition to backup power, ensuring that the servers and other critical equipment continue to operate without interruption. The emergency power system is regularly tested and maintained to ensure its reliability. The data center also has a detailed emergency plan that includes procedures for responding to power outages and other emergencies. Another example is a hospital. Hospitals rely on emergency power systems to provide power to critical equipment such as life support systems, operating room equipment, and patient monitoring systems. A power outage could have life-threatening consequences for patients. To prevent these consequences, hospitals have installed emergency power systems that include generators, transfer switches, and UPS systems. In the event of a power outage, the transfer switches automatically transfer the load from the normal power source to the generators, which provide backup power to the hospital. The UPS systems provide a seamless transition to backup power, ensuring that the critical equipment continues to operate without interruption. The emergency power system is regularly tested and maintained to ensure its reliability. The hospital also has a detailed emergency plan that includes procedures for responding to power outages and other emergencies. These examples illustrate the importance of emergency circuits and systems in protecting lives and property. By following the proper installation procedures and adhering to all applicable codes and standards, you can help to ensure that emergency circuits will function reliably in the event of an emergency.